Hi everyone, welcome again to my structural analysis video, and this time we're going to solve the previous problems, the beams, the rigid frame, and the space truss using the SAP 2000 software. So first we're going to solve this problem, the beam problem. Now let's proceed with our software. So in our software, this is the command window, and what we're going to do now is to create a new model. So first is we have to take note on defining the units. We need to define the units corresponding to the given unit in our problem. So click grid only, and then as we can observe from our figure, we have to divide the grid that will serve as our nodes. So our nodes here are there are 1, 2, 3, 4. So I'm gonna create 4 grids. Well, basically we can divide this this member here into 2 for the purpose of assigning the point load, or actually dividing it to we're going to assign nodal load later. So it will pertain the same analysis result. So let's go proceed and plot this into our software. So we have again 1, 2, 3, 4, and then along the y direction and z direction, let's put it 1. Then as we can see from our figure, its length is 12 meters, so we're gonna put 12 meters, and then along the x direction and 1 along the x and y, the y and z direction. And click OK. And in a window, there are 2 windows actually. It will present 3D view and the two-dimensional view. So since I'm not going to use the 3D view, I'm going to exit this and we'll focus on designing or plotting in the 2D view. So from our inputted data about the grid, so they're not actually exact to what is given in the problem. So I'm gonna edit the grid data. Just click right click in space and then edit, click edit grid data and then modify or show system. So these are the parameters, so 24, and then we're just gonna edit this. I'm gonna add this is supposed to be 24 plus 4, that's 30, that's 32 plus 4, that's 28, and this is 32. Then let me click OK and close. And of course I actually did not see the change because I am in a wrong orientation. So let's correct the orientation. It's actually XZ view. So we click the XZ view and then it will show us the view. So then after that, we have plotted and set our grids as our points. So let's draw or fly a frame, and upon plotting the frame, it will actually show us the length. So that's one step of verifying that the length or the distance of the grids are correct. That's 12. Click, and then another click. That's 12. Then it's just 4. That makes it 8. Then exit. After that, we're going to highlight the endpoints in order for us to then assign our supports. So let's click assign and joins and distance, and then we can click the type of support here. So from our given, those are all fixed and supports. So I'm gonna click fixed. I'm gonna drag this to visualize the application of the loads, or actually the supports of the process. I'm gonna click this and then apply, and there the supports are already applied. So we're going, and then next we're going to highlight the node here from B. There's 12 meters from the origin, because from our given problem it's actually a roller support. So there's a roller support given, and we just have to apply, and then it will show us, and then click OK. And after that, Let's define our materials, section materials. So our materials, we're going to modify add a new material. So it's actually a concrete, customary user, and click OK. And then doing the user mode, we can actually edit, based on the given assumed material properties. So our material properties, the weight per unit volume, that is actually 24, and this is 21 million. This is equivalent to 21, that's 21 newton per meter, so it's equivalent to 21 kilonewton per mm squared. So, and then the coefficient of thermal expansion is 0.1234, 12. And then we click OK. After that, click OK. And then after defining the material properties, we're going to define the section properties, of course. So we added new section properties. So our section properties is actual rectangular property, our rectangular section. Now we're gonna input the given, that is 400 by 250 mm. So this is 0.4, while this is 250. And then we assign or define the material as a concrete, and click OK. So that's OK, and then we click OK, and then modify software concrete. I'm gonna name it concrete and rect. Okay, so after that we have already assigned the supports, and now we're going to assign the loads. Before that, let me define first the loads on the load pattern. So we already have the dead load, and we're gonna add the live load. Live load, and this is live. Multiply from the pilot. So okay, and then add a new pattern and then click OK. And after that, we are going to define the load combinations. Add a new combo. Let's add dead load and the live load. Add. Then we will name that combination 1. So click OK and then OK. And after that, we're going to assign now our loads. So our load is a uniformly distributed load. So the distributed load, let me highlight this section in this point. It's part of the view. Then we're going to apply our uniformly distributed load is 20 kilonewton per meter. So actually 0. This is a live load. Then click apply. Then we can see the applied load here. The applied load is 20 kilonewton per meter. And then for that, next we're going to assign our nodal load. So if I haven't put or designed or inputted or plotted the structure with this separated with the node, in between this number, so I can actually assign still assign a frame load that is a point load. In this case, I have put a node here, so I'm gonna assign a joint load. Assign a point load that is on 100% length, in the whole length. This indicates that your actual this is an indication or an indicator to where you actually want to put your point load. So in this case, since this is the middle point to which the applied point load, the live point load, so actually has to be applied. So I'm gonna put here at 1. It's 1 means it's on the edge portion of that number. It's on 250 according to our given, and then click this member and click apply. Then we can see the applied live load. Click OK. Then after that, we're going to assign number, type of the material, and then click apply. Then one of the indication that the properties are already applied is word rect here. Then click OK. Now we are ready for the analysis. So what we're going to do now is run analysis. Then I'm going to highlight the live, and then run now. And we're gonna save this the dash underscore beam, and click save. And then it will show us the results. So these are actually the reactions, no? So these are the reactions, the support reactions in the moment along this portion. So actually in our in this the objectives of this activity is to identify the different values. So using this, we can actually identify. We can already identify by running the analysis. So here we can actually show the combination one. We can show the forces along the actual force, the shear force, and etc. So for example, let's say the moment, this combination one will apply there. So I'm gonna show the values. Apply. There. So there we actually had the results. So that's it. I hope you have learned something about this video, and thank you for watching. And please watch out for the next video. Again, using this software but on different problem. Thank you.